Good afternoon and welcome everybody to what is the second in our spring series of Climate Smart webinars. I'm Ben Wixey and I'm joined by Bailey Archibald from Germinal Ireland and William Fleming from Germinal GB. And we're here to discuss the benefits and practical uses of clover to help reduce emissions in livestock. Germinal and our parent company Openfold, we're 200 years old this year, so happy birthday us. We breed grass and legumes at Germinal Horizon which is embedded in Aberystwyth University. And as a family business, we celebrate obviously our heritage, but more importantly, we're looking forward. And our new range of climate smart mixtures has been designed by our grassland specialists with performance and sustainability in mind. So you as a farmer and your stock, to help you meet the challenges that you face today and those that you will probably face tomorrow and going forward. We heard in the first webinar in the series, which is available in the knowledge hub of the Germinal website. We heard there about the benefits in production and the environment of the high sugar grass. And today we're going to focus more on legumes and specifically clovers. Our team of breeders are not only working on white clover and red clover for today's farming, but also the next generation of innovative legumes for the future. Claire, over to you.
So just a little bit about myself before I get started. I'm in the agricultural sales team in Ireland and I'm based in the northeast. So, Meath up to the northern border down to Dublin and out to Westmeath. I'm Australian, so I'm a direct import and exchange for all the Irish people that have left to go to Australia. And I've been here for about 3 years and my husband and I are farming together with his parents. So what I want to cover today is a little bit about the climate action targets, just very briefly, just to touch on them. And then I want to talk about the white clover plant, how it grows, and the same for the red clover plant, and then touch a little bit about our innovations. So just starting with our climate action targets. So we are looking to see in Ireland a 25% reduction in greenhouse gases in ag by 2030 and 22% reduction in greenhouse gases for agriculture in 2027 by 2027 in the UK. So that is quite a challenge. And I guess what we want to touch on here is how clover can be of use to help you get there. So greenhouse gases like nitrous oxide come from nitrogen fertilizer applications, and then your methane comes from animals and slurry spreading. So this is kind of a conversation for how our legumes can help us out. A small plant with a big impact. I am a long-term fan of the old legume, so it's great to see that there is so much interest in clover in our grazing swards and silage swards across Ireland and the UK. So it's a highly digestible forage, so it's low in fiber, which encourages greater intakes. So that's an intake increase of about 8 to 10% in dry matter. They have a high protein content, which is adding to the overall energy balance. So from that perspective, they're able to eat more and then have more protein in the diet, which is of great benefit. And then it has a Clover has a D value of around 70%. So it is bringing something to the party there. In terms of soil health, there has been so much interest in soil health over the last sort of 7 to 8 years in agriculture across the world. People are really starting to take stock of what's happening under the ground. To me, I think monocultures are sort of the days of the monoculture are gone without, a good agronomic reason. And it's really important to see that we're having more than one type of plant with the addition of clover. It's of great benefit to our underground bugs and the microfauna and flora that live in our soil. And the big ticket item from a farming perspective is the nitrogen fixation. And nitrogen fixation is important to us from a profitability point of view. It's good for our back pocket. And from an environmental perspective, there's less losses of nitrogen through the system if we're able to utilize legumes and adjust our fertilizer applications accordingly. And it's not that the legume is bringing quite a bit to the party. So it in white clover, say, produces 150 kilos of nitrogen per hectare, the clover plant is using about 75 kilos of that, leaving the remainder available for the companion plant to take up. So there's quite a good quantity of nitrogen there available. And just to not ignore our pollinators, they do a huge amount of heavy lifting in agriculture for a lot of our food crops. So, you know, having the benefit of clover flowers is really important. Now, you won't have a whole field of clover flowers, but definitely, you know, having little bits of flowers come on through the year is definitely beneficial to our bees. So when we get down to the business of what the engine room of the whole legume is, it's the nitrogen fixation. It's the relationship between rhizobium bacteria and the clover plant. So this relationship occurs when the plant has said, hey, I can't get enough nitrogen in the soil here, and it sends out a signal called a flavonoid, which is a chemical signal into the soil that lets the rhizobium bacteria know that it wants to make a relationship. So a fine root hair will kind of curl over and make a shepherd's hook, and then the rhizobium will come in and infect the fine root, and that will go all the way down into the main root system, and a nodule will be formed. So that is the beginning of the relationship. From there, the rhizobium is able to capture atmospheric nitrogen, store it in its nodule, and as the nodule dies down, it then becomes available for the companion plants to take up from the soil. But what do we need to make that happen? We need to have a good soil pH. So we're really looking for a pH of around 6.5. Do you know, nitrogen fixation is driven by pH. So if your pH is too low, it doesn't foster the rhizobium bacteria. So it's really important to ensure that that's right. We also need to make sure we have adequate nutrition in the soils, and soil testing is a must. And from an environmental perspective, we need to have 8 to 10 degrees soil temperature to allow nodules to fix nitrogen. And also we need warm, sunny days and adequate soil moisture. So wet feet is not going to help. So we need to make sure that we have dealt with any drainage issues we have in the field. So I just want to talk about this little white clover plant. It's small but mighty. So on the left-hand side of the screen here, this is an 11-month-old white clover. I dug it up myself last week from my silage sward, where I have red and white clover silage in. So in terms of plant characteristics, this white clover is hairless. It's nice and shiny. The leaves have a watermark, and it's a low-growing plant. And I like to think of it as an umbrella. It's got these petioles or stalks that hold the leaves up, and it makes a lovely canopy. So when you're looking in the field for white clover, you've generally got to get down so you can actually see it at this time of year, because it will be sort of covered over by the grass. So we expect to see about 150 kilos of nitrogen per hectare per year provided by this plant when it's in its optimum growing conditions. One of the things we don't talk about so much are the growth phases of white clover. And so I think it's important to touch on that here, because it really dictates then our future management. So when we sow white clover, it starts out in the rosette phase. The rosette phase lasts from 0 to 3 months. This is where the plant is forming a central taproot, and it's really getting its engine room up and going. So it's important to look after the plant here, not graze it down too hard, but grazing is beneficial. And it's not fixing any nitrogen at this stage. It's just simply growing and ramping up for its next phase, which is the expansion phase. This phase lasts for about 3 to 6 months post-sowing. So at this stage, the plant is still reliant on its central taproot, but it's starting to expand. So it's starting to kind of get a bit of energy there, and it's getting bigger, and it's getting ready for its next phase. So you would actually expect to see a small amount of nitrogen fixation here, but it's not enough to carry a companion crop. So there'll be a little bit of nodulation, but it's not in full swing just yet. Our next phase is the clonal phase, and this is what we think of when we think of white clover and its stolons. So when it gets to this stage of growth, it's starting to expand and put out stolons. And if you just look here, This clover plant that's 11 months old is starting to produce a stolon. So it's got its unfurled trifoliate leaf, its petiole, and here at the node you can see there is an adventitious root. It's these adventitious roots that are actually our primary source of nitrogen fixation once the plant is developed. So it really takes well into a year and a half for a white clover plant to actually establish and to be getting to fix nitrogen. So, and when I dug this little guy up, it did have some nodules here on the left-hand side of the screen. They were pink, which means they're fixing nitrogen, but there was nowhere near the quantity as to say when I dug up my red clover plant. And that's just my next point actually is if in doubt, get the spade and dig it up. Nothing beats actually having a look. Just moving on to red clover. So red clover plants are a completely different animal. They are tall and they have hairy leaves and hairy petioles or stalks. And that's a real key feature to telling both red and white clover apart. Unlike our lovely taproot system on our white clover, which I forgot to mention will eventually die away, the red clover retains a lovely long taproot, which is really important to, its drought persistency. And so it's a really interesting plant because it takes well into a year for our white clover to start fixing nitrogen, but our red clover plant starts fixing nitrogen from about 6 weeks post sowing. So you plant your red clover and then you're really getting the benefit very early on in the piece. So from an identification point of view, your red clover has a crown. It has no stolons. So this is a really key point for your management of your red clover. If you cut the crown off, the new growing points off, you no longer have a viable plant. So it's just very important that when you go to graze or cut for silage, you go out and you actually have a look at where your crown is on your plant so that you don't accidentally cut it off because that wouldn't be great. And we generally expect to see yields of about 15 tonnes per hectare when it comes to red clover of dry matter. So very much a different type of plant to the white clover. And it fixes about 200 kilos of nitrogen per hectare per year. So it's a strong contributor in the system. And we need to talk about a couple of things that are important to red clover. So there is pests and diseases that we need, or pest and disease considerations. So we have an issue that comes up with stem nematode and also crown rot or sclerotinia. Now there's no chemical control for these two issues. They need to be managed culturally. So it's really important that you have a 5-year break between red clover crops because basically you're removing the host plant so that then they can't proliferate in the ground and cause you problems. And in terms of phytoestrogens, it's just also important for us to say that, if you have breeding ewes, you need to take them off red clover 6 weeks pre and 6 weeks post mating so that there is a risk of temporary infertility. So you don't want to be grazing them or feeding them on red clover or feeding them red clover silage. So this brings us to polyphenol oxidase. This is what makes red clover so special and so useful in our system. Polyphenol oxidase is an enzyme that's found in the leaf of the red clover plant. And what it does is it enables the protein to be better utilized through the digestive system of the animal. So that means that we're having less losses in the back end and you're able to make more meat or more milk out of the plant material that the animals are consuming. And just recently, some very exciting work has come out at the BSAS, the British Society of Animal Science. A couple of weeks ago was held in Galway. And Sarah Woodmartin presented a paper there where it showed that perennial ryegrass and red clover lambs that were grazed on perennial ryegrass and red clover showed a 13% reduction in methane emissions. So not only are we benefiting by reducing our on-farm nitrogen application, we're getting a double whammy and we're reducing our methane emissions as well. And also the lambs were finishing faster on red clover. One of the things that often comes up for us when we're out on farm or talking to farmers, it shows is, what's the persistency of red clover silage or red clover in general? So we would say for your conventional varieties, we expect to see 2 to 3 years persistency. And I will preface that by saying that all comes down to management on farm. And then with the newer varieties like Aber is known for its persistency. We're expecting to see 4 to 5 years, if not 6. So, Aber is currently being used in some silage trials at Grange. And now, just for our UK contingent, Grange is part of Chagas, and Chagas is the Food Development Authority. So they do a lot of research and training within the agricultural industry. So currently, there's some work being done there with red clover silage, and Aber is showing very good persistency here. And it would be remiss not to talk about the breeding for innovation that Germinal is doing. Germinal has an absolute passion for plant breeding, and that 20% of our people are working in plant breeding and research. So we've got a lot of good things coming. So we have currently on the market, we have double root, which is known as Aberlasting. Aberlasting is a hybrid between white clover and Caucasian clover. Now, it looks like white clover, but it has some of the really good traits from Caucasian clover. So it has stolons and rhizomes. So that makes it extremely drought tolerant, cold tolerant, and grazing tolerant. So it's a really interesting clover, and it's currently in our Climate Smart range. And I think people will get a lot of benefit out of it, in those tricky conditions. The next thing we have, which people may have heard of, is Red Runner. Red Runner is really exciting. It's a stoloniferous red clover. So like our white clover that makes its stolons and has adventitious roots along the nodes, the red clover that will be Red Runner is like that. So it will be very persistent under sheep grazing and the like. So it's currently in simulated grazing trials, and it's doing very well. The third one here is bird's foot trefoil, which is Lotus corniculatus. It's not currently used in wide or used everywhere at the minute. You can see it mostly included in multi-species swards. It's a forage legume, and it contains a type of tannin. Now, this tannin enables the protein to be better utilized, and it has the potential to reduce bloat. And like our chicory, which we talk about, that has an anthelmintic or anti-parasite property, so does our lotus. So it's a very exciting little plant, and Germinal currently have it in a breeding program for persistence, and they're working on a germplasm. And that's, watch this space, because it could be a very useful plant, or a tool in the toolkit, as we like to say. Last but not least is New Leg. Now, people may have heard of New Leg before, but I just thought it'd be worthwhile covering here. New Leg is a really exciting project where we're aiming to, tailor rhizobia to the right legume plant. So getting the two to work together to their best. So currently, white clover can fix 150 kilos of nitrogen per hectare. But if it had a particular strain of rhizobia that enabled it to fix more nitrogen, that could be hugely beneficial. So you may be able to double your nitrogen. So that project is worth about 4.7 million overall. So it's a really big project. And Germinal is leading this project with 10 partners. But they have 14 demonstration sites planned in the UK. So that project is over in the UK, but hopefully us in Ireland will be able to benefit from it in the long term. So thanks very much, and I will pass over to William.
Thank you, Claire. William, over to you.
Thanks very much, Ben. As Ben said, I'm William Fleming. I'm Area Sales Manager in Scotland and the north of England. And for my sins, I'm a part-time pedigree sheep breeder. It was quite interesting seeing the results of the first poll there, and hopefully for those of you that have not got a lot of clover and would like to use more, Claire has persuaded you of the benefit of one of nature's great alchemists. And in this section, I'm going to try and cover some of the practicalities of managing white clover, and hopefully a little bit about some of the financial benefits that we get as well, which will make us more financially sustainable as well as environmentally sustainable. We have to start right at the beginning and how we establish clover. Normally, we like to do it when we're doing a full reseed. Whichever method that a farmer like to do your reseeding. I have no particular preference. They're all very effective if done well. The slide here is a slide looking at overseeding. I find this slide a little bit disconcerting because there's more grass there than I would like to see in this situation for overseeding. We want to get it eaten really tightly down, make sure there's no thatchy material there before you go in and overseed. We want to make sure that we get our P&K indexes right before we think about introducing clover, because legumes are phosphate hungry in particular, and we really want to get them up to indexes 2 for both P&K here in the UK and in Ireland, index 3. If we're on really sandy, light land, or it's been following cereals for 2 or 3 years, then we would think about adding a small amount of nitrogen at establishment, but only in that situation and up to a maximum of about 50 kilos per hectare. But we want to get this white clover established, and to give it the best chance of establishing, we need to have the warm soils. Claire was saying earlier that we're looking for 8 to 10 degrees to get the nitrogen fixation. We need soil temperatures to be consistently above 8 degrees to get the clover to establish and grow. So ideally, we're looking for that consistent temperature. We're looking for light. We want to get it well grazed down. We need moisture there as well. So it depends on where you are in the country, the ideal time for doing this. There are great differences both here and in Ireland in terms of the strategies for introducing clover. One of the strategies we use here is, in a grazing situation, wait until after mid-June when grass is in its natural lag phase, and then get your clover in as long as you've got the sward well enough eaten down. Or in a silage scenario, wait to probably early August after you've taken your last cut. Soils are still warm enough, you're not fertilising it, to allow the plant to establish without too much competition. I know Claire tells me in Ireland, a lot of the clover that's stitched in is done at this time of year, and then they manage the sward by keeping it well grazed down in the spring to make sure to get the light there and the clover plant established without doing any damage to it. So there are different strategies to getting it established. Having seen some of the results of the polls, there's some of you don't have a lot of clover, and one of the reasons, or the two big reasons, are firstly weeds. You say, I have a big dock problem, I can't do anything about them, or I struggle to do anything about them, so why put clover in? Well, I'm not an agronomist in any way, shape or form, so it's vital that you take and consult your own agronomist before doing anything. But there are two major strategies to dealing with it with chemicals. You can do a pre-reseeding, control your docks, or after you've reseeded. Now, the pre-reseeding one is great as long as you're doing a kind of minimum tillage or a direct drill, because if you do a full tillage reseed and you've got a lot of dockings, once you plough it and turn that soil over, there's a lot of dock seeds, up to 80,000 per plant produced yearly, and those dock seeds can last in the soil a long time, up to about 50 years. So you're then exposing the perfect scenario and the perfect situation for those that seed bank that's in the soil to germinate. And then you have to rely on a post-reseed treatment for the docks. Now, this is where, in the past, a lot of people wouldn't have used clover because they say, oh, I have a dock problem. What's the point? Because if I spray it, I'll kill it. But there is now a new product in the market. It was launched in 2024 in Ireland, and the company tell us that it went straight away to being their biggest seller last year. That product has been launched in the UK this spring, and having been at their Scottish trial site last August it was, this product appears to work really well and is a very useful tool in the armoury to encourage you that clover is still a big part of your reseeding programme. The other issue that crops up, particularly for a lot of you that have only got that kind of 1 to 5 or 5 to 25% clover on your grass leaves, is bloat. This is a big issue because there are high risk situations particularly when you have got dairy cows going out in the morning, they're hungry, they've just been milked, and they go into a lush pasture with a lot of clover in it, and it's a wet, cold morning. The risk factors are all there for bloat to be a big issue. Now, there are mitigating ways to do that, and I know it's not easy when you're working a rotational grazing system. In mornings like that, where you don't have a lot of clover, perhaps use one of the fields that doesn't have any clover in it, or alternatively have some long fibre there to take the edge off the cow's appetite before they go to the grass, to try and reduce the risks in this situation. And one of the things that I know a lot of our Irish colleagues see a lot is bloat oil being used in water troughs, and that seems to work really well. So yes, this is an issue, and it does cause deaths in cattle, but with a bit of thought and a bit of planning, there's no reason why it should be an issue to stop you including clover in your swards. Now, let's get on to some of the financials that Claire was talking about, making everything more financially viable. This is work from a trial that was done at Ibers. It was done over 3 years in an attempt to try to take away the statistical anomalies of the weather and how grass grows. But it was based around a grass-only sward receiving nitrogen and a grass and clover sward with less than half that nitrogen applied. And over the course of the 3 years, the grass and clover with the greatly reduced fertiliser produced over 4.1 tonnes of dry matter more per hectare than the grass alone with the high fertiliser use. So straight away, we have the fertiliser saving there. These prices were prices that I got earlier on this month. In the UK, nitram at £380 a tonne. In Ireland, canned sulphur at 410 euros, excuse me, 410 euros per tonne. So over the lifetime of that trial, there's massive savings to be made there on the cost of fertiliser, and all for the cost of either in the UK £35 a hectare for the clover seed, or €35 a hectare in Ireland for the clover seed as well. It really begs the question, why are we not thinking and not using clover and everything? The other big one about clover, Claire mentioned the fact that we have the high D value in clover as well. It's something that we are guilty, and I know I am personally guilty of it, is forgetting about the energy and the D value of clover. We all fixate on the nitrogen fixation and the crude protein content of it. But this energy is a big, big boost for the livestock in terms of intakes and performance. And this is based on having 20 to 30% white clover inclusion. That's the sweet spot in terms of the inclusion rate we're looking for in a dry matter basis. Now, this is work that was done a few years ago over at Cheggers, and really the line I want to draw your attention to is the Moore Park set of results. When you look at grass only and 250 kilograms of N compared to the grass and clover with 150, you've got 33 kilograms more milk solids per year, which is over 300 litres for those of us in the UK extra on that grass-based system. Now there you have a big benefit in terms of your milk income, because an island paid on solids, but also the reduction in fertiliser. And some of the calculations that Cheggers did equated to a net profit with the white clover and the reduction of €305 per hectare. And I know that there's currently still work carrying on in Ireland, where they're now looking to get that in grass and clover and nitrogen applied down to less than 100 kilos. So it'll be interesting to see how those results pan out in time. Now, we've talked a lot about clover, but how do we classify clover? We look at clover and classify it by leaf size. It's quite important when you're selecting the clover that's most appropriate for your system. If you're sheep grazing there, as you see on this side, we want the smaller leaf clovers, and the reason for that is that they put up more leaves, so they have more petiole, so they're more adventitious roots, so they have a better anchorage to the ground, so they're less likely to be damaged by grazing. But the downside to that is they're lower yielding. Where we have dairy cow grazing or silage ground, we're looking at these larger leaf clovers. They have less leaves, less PTOs going up, so they then have less adventitious roots going down. So there's less anchor points to hold them to the ground, so there's a greater risk of damage by grazing. So therefore, the persistency is much reduced. And we've talked quite a bit about the clover content of the swards, and one of the rules of thumb is that when we look down on a sward, we look at the grass, and the grass leaves are coming up looking at us. But as Claire mentioned, the clover leaves, when you look down, are like an umbrella. You're looking down onto the top of them. And it's very difficult to be able to assess the clover content of your sward. Just take a wee look at those two pictures there. You take whatever you think is the content and half it, and that will be the amount of clover that's there. Claire mentioned earlier about the red clover, and they've been hairy. Now, there's just a nice image to highlight that, and that really is the classic easy example to show you the difference when you're walking, whether it's a red clover or a white clover. If it's hairy like that, it's definitely red. If it's hairless or bald, it's more likely to be white clover, or will be white clover. We all think about the legumes as fixing nitrogen all the time, but we actually forget that legumes, they are also nutrient hungry in terms of phosphates in particular, and potash as well. We're looking to get, in particular, red clover indexes +2 in the UK and 3 in Ireland again. And in a scenario where it's a red clover only stand being utilised to produce high protein silage, we're looking at 12-15 tonnes of dry matter produced. Well, there's a big offtake in terms of phosphate and potash there, and we need to replace that. So we need that 8 kilograms per tonne of phosphate removed, of silage removed, to replace it, and 27 kilograms per tonne of dry matter removed for potash to replace it as well. Sometimes, in a lot of cases, that will come from slurry, but in that situation, it's important that you actually analyse your slurry so that you know what you're putting back on, because to get the best out of the red clovers, we need to supply that nutrient content there. So analyse your slurry, know what you're putting on, and know what you need to replace from other sources. We talked a lot about the utilisation of red clover for silage, and I think it's a fantastic crop, and one that we don't utilise enough, but it's becoming more popular as people realise the benefits from it. The big thing about a red clover and grass sward when you're doing silage is you have to raise your cutting height. As Claire said, we want 78 centimetres so that you don't damage the crown. And the big thing is that the protein in your red clover is in the leaf, so we have to protect that leaf at all the stages of harvest. We want to get as much of that leaf from the field to the clamp as possible so that we have a high quality, high protein silage for feeding stock during the winter. So we don't want to be cutting it with the traditional flail conditioner. Preferably, I like to see it done with either a roller conditioner, which is very rare nowadays, or just a plain mower, keeping the height up and spreading it behind the mower straight away. We don't want to be going in with a tedder onto a red clover silage just for to keep the leaves as intact as possible. And when you go to roll up your red clover silage before you ensile it, the rule of thumb that I was always given was when the dairyman or the man that's milking the cows goes out to the field to bring the cows in, somebody else goes out with a rolling up machine to roll up that red clover silage nice and gently when there's still a dampness and a dew there to help to maintain the leaf as intact as possible. Personally, I like to see red clover silages lifted with a forage wagon because, again, you're keeping as much leaf there as possible and getting it into the clamp. For most of you that have carted silage, when you're following the chopper and you see the silage getting blown into a trailer, there's a puff of grass coming out the trailer. If you're in a red clover silage, that's the leaf that you're losing. You're losing and leaving that protein in the field. So that's why I say my personal preference is to get it done with a forage wagon, to get it as much of that leaf into the pit as possible. Now, again, very similar analysis for the red clover as the white clover. But the one thing I want to draw your attention to is the crude protein analysis. Now, we now use NIRS as the standard for analysing silages to ration cows. But NIRS is not the best tool for utilising and analysing red clover silages. There are two reasons for that. The first reason is that the NIRS program has been built up over years with lots of calibrations from grass silage. But there's not enough calibrations done with red clover silages to give us an accurate crude protein analysis from our silage. The only way to get that is with a weight chemistry. And to complicate matters further, the red clover content in your silage changes with the cuts over the course of the season. Your first cut is going to be predominantly grass with a little red clover in it, but by the time you get to your third cut, it's going to be predominantly red clover with far less grass in it. So you're changing the balance of that silage, so that makes it more difficult as well to get an accurate analysis. Generally speaking, if you don't do a weight chemistry, nutritionists tell me that a red clover silage will feed as if it's 2 to 3 percentage points higher than the analysis tells us it does. As Claire said earlier, grazing red clover after mass with lambs is a fantastic way. That work that Sarah Woodmarsh has done just really backs up a lot of the things that we see on the field year in year when people are grazing lambs and finishing lambs off of red clover leys. But it's important to remember that lambs can also suffer from bloat, so you've got to adapt them to it as they go onto it. But once they go onto it, they will absolutely fly, and you get fantastic growth rates and finish on your lambs with red clover. And as Claire said, and I can't emphasise this enough, don't top or mate use on red clover grass silage, grass leys. It has the potential to severely impact on ewe fertility. It is a big risk. Today, we have been focusing on legumes and the part that they play in productive sustainability. And that goes right across the new Climate Smart range that we have launched this year. But a big emphasis on legumes is in our capture range, where we're looking at utilising more of our legumes to produce more sustainable grass, but at the same time doing it productively. And just to kind of summarise the benefits that we get from our legumes and our clovers, is they fall into two characters. The productivity element of it, we're increasing protein supply, we're increasing the energy supply, and when you increase that energy supply along with utilising the other high sugar grasses, you lift output from your stock and performance, either litres of milk or live weight gain. It is the combination of the increased energy supply and the increased dry matter intakes. And then we have the sustainability element. These legumes are nature's alchemists. We're fixing that atmospheric nitrogen that's 80% of the air round about us and utilising it for the legume, but we're managing to utilise the excess that the legume doesn't need for our grasses, our companion grasses, to produce without the environmentally damaging purchase of artificial nitrogen. The artificial nitrogen has a big problem in terms of its carbon footprint from the production, the transport, and then we have the application losses. And the other thing is, it is a highly volatile commodity and very expensive. So thank you very much for your time, for listening. Before I hand back to Ben, I'll just put this last slide up. For those of you that wish, you can click the QR code there to sign on for our last webinar, which will be on May the 14th, when we look at the ADAPT range and looking at how we can utilise that in agriculture going forward. Thanks, Ben.
Brilliant. Thank you, guys. Quite a few questions come in. One of the things we have learned from the survey over the years is that 50 to 55 minutes is about the right length for one of these webinars. So we are not going to get to answer all these questions, but a few of them here. What are the trace elements needed in soil for nodulation? Claire, do you want to cover that?
Yeah, sure. So I guess there's an overall comment to that is that you need to have your P and K right, and don't forget about sulfur. We talk about sulfur for grassland in general, but it's also key for fixation and development. If it doesn't have it, you won't get as good of nitrogen fixation. From a micronutrient point of view, you're generally looking at cobalt and boron, calcium and copper are important for nodule formation and development. Now, that doesn't mean that you should just go and put on a whole pile of micronutrients. You should always do it by a soil test. You can have those sorts of assays added on to your standard soil test, but you might say be suspicious of a field that is very, very sandy, because naturally very, very sandy soils don't have the ability to hold on to as much nutrient.
Good, good, thank you. Does it take 11 months to start fixing nitrogen? Your plants are 11 months old, I think. Do you want to comment on that, Claire?
Yeah. So generally you have a little bit of nitrogen fixation at the 4 to 6 month mark, but not enough to carry the companion crop. And it's not until those adventitious roots are, your stolons are formed and you've got lots of adventitious roots to allow for more nitrogen fixation. So yes, it does take that time. And that's why it's really important to, pay attention to the recommendations for fertilizer. You wouldn't just cut it out completely in a new clover sward, because you will run into problems.
Thank you. I'm gonna add to that answer with another question that's been given is, how does crimson and berseem clover compare in terms of nitrogen production in cover crop scenarios? Well, obviously berseem clover and crimson clover are annuals as opposed to the perennial white clover. So they tend to grow quicker and they tend to fix nitrogen quicker, which is why they're more in the cover crop mixtures than a standard perennial. And a lot of those cover crop mixtures are only down for 12 months at most. So crimson and clover, berseem clover, yeah, they're not as winter hardy. We have struggled getting them to grow back after cutting, especially if you let them get really long and tall like a vetch. If you get them to maximum amount of dry matter and then you cut them off, that we do struggle to get them to come back. But in terms of fixing nitrogen, that they will fix a bit quicker than that. And obviously when you cut a crop or you graze it hard, that's stressing the crop, and that is one of the times that you will release the nitrogen that's stored in the nodules under the ground. So as you stress the crop with a cut or a mow, so the nitrogen is relieved to the companion plants, and those will grow more and more. Okay, question here. Am I best to keep my red and white clover separate for grazing and silage, or can I sow them both together in grazing and silage ground? William?
In silage ground, it doesn't matter. I would say the important thing in the silage lays is that you make sure you get an adequate amount of red clover to get the benefit. So I would be looking for 3 kilos to the acre in your silage one, and then perhaps a kilo of a large leafed white clover in there as well. In a grazing scenario, if you're grazing beef cattle, it won't matter, or dairy cows, if they're both there. Where sheep are involved, it gets more complicated. And in a sheep scenario, I personally, and this is a personal opinion, would probably try and keep them separate so that you have got your red clover for making silage on, and then finishing your fat lambs later on in the year. And you've got the white clover there to be supplying and fixing nitrogen and growing your grass for your use at other times of the year. I'm just thinking about the mating aspect, and that's why I think for a sheep scenario, I would keep them separate.
We do have a trend of using red clover perennial ryegrass as a 4 to 6 year sward, and now there is a trend of putting a kilo of white clover in the bottom of that, so that when over time the red clover does disappear. You've still got some white clover there in the bottom of the sward because you've got a perennial ryegrass sward. That sward could stay active for another 4 or 5 years with the white clover in the base of it and become a grazing sward. Wouldn't do the same thing with short-term grasses, with Italians or hybrids. We wouldn't particularly advocate growing them with red clover, but wouldn't put white clover in those either. They're a short-term late. Does large leaf white clover fix more nitrogen compared to a small leaf white clover? I think the answer to that is probably you've got to get the right size clover for the management you're going to impose on it. If you don't have the right clover there, it isn't going the right size, leaf size, and therefore resilience to the management you're going to imply on it, it isn't going to be there, and therefore it's not going to fix any nitrogen. I'm struggling to think of a paper or any science that says there is more nitrogen fixation from a large leaf over white, given everything else being equal. I've seen plenty of work that says there's a much thicker stolon density with smaller leaf clovers, but I don't know that I can make a connection to more nitrogen fixation from white leaf. But again, going back to the New Leg project that Claire mentioned, getting the right rhizobium to fix with that nitrogen, with that clover plant, is going to give us a much bigger uptake of nitrogen than worrying about whether the leaf size is quite right. Then one here, I know I've got an answer for this if you want. How would sowing red clover as a monoculture affect my silage quality compared with perennial ryegrass on red clover?
The comment I would make on that one, and you can come back on that one, Ben, is that yield-wise, it will be the same, very similar. The big challenge with a red clover silage on its own is you need to have a high quality additive with it to ensure your fermentation, because there's not a lot of sugars in the red clover. It's the protein that's there, so you're going to produce a very high protein silage. And on a monoculture red clover, I really like to see that silage either baled or kept in a separate clamp, so that you can utilize that as your protein in the ration, in addition to your grass silage, with input from a nutritionist to get the right quantities there to feed the stock. So I would say that would be my comments on a red clover monoculture silage.
I wouldn't be a fan of a red clover monoculture. If you think about the plant and it's fixing nitrogen and then releasing that nitrogen during the course of the summer, where's that nitrogen going to go if you don't have a companion crop with it to soak it up and utilize it and grow a grass crop? I think we're much safer to have a perennial ryegrass crop with a red clover. So one last question, I think, because time's pushing on. Can I use digestate on my newly established clover swords?
The simple answer is yes. The complicated, long-winded answer is that it is very, very important that you actually know the analysis of the digestate you're putting on. From what I understand, the analysis of the digestate is very much determined by the feedstock that goes into the ED plant. So it's crucial that you get an accurate analysis, and when you're then applying it, you have some means, whether it's a contractor or a flow meter on your own equipment, to know the exact amounts that you're putting on, so that you're matching nutrient requirement with nutrient addition.
Brilliant. Thank you. And I am going to wrap it up there. Thank you very much. So once again, thank you everybody for taking part. Thank you for all the questions, and have a good day.